Hello there. Today I want to look at this problem, which is not necessarily complicated by any means. The solution is fairly simple and straightforward, and you don't need to know a lot of math to get there. But what might be a little bit of trouble for some people might be how to get there and how to actually figure out where we need to go. And that's why I'm doing this video today. So the question says, given that A, B, C, and D are positive real numbers, and A and B are both larger than C plus D, we want to show that AB is greater than AC plus BD. Alright, so how do we solve this? If you wish to pause the video and have a think on your own, you would be most welcome to. But otherwise, let's get straight into it. Here's the question at the top. For now, let's just observe what we were given and what we have. We have these two inequalities, and we have one final inequality that we need to prove. We might notice that if we look at this inequality, for example, and it's the same for the other one, if we multiply A on both sides, we might get AB on this side and something else on the right. And the final inequality we need starts with AB on the left. So this might be useful. So let's just try it out. So we know that A is greater than 0. So when we multiply both sides of this inequality with A, the sign would stay the same. It would not flip as with a negative number. We can multiply both sides and we would get AB is greater than AC plus AD. The good news is this looks fairly similar with what we want in the end, but the bad news is it's not exactly the same. We want AC plus BD to be less than AB. We don't want AC plus AD. It is differing by this one term. Now we can try the same thing with the other inequality. Of course, this time we're multiplying it by B. We multiply it, we get AB is greater than BC plus BD. But once again, we want AC plus BD, not BC plus BD. There is a single term that is different. Now, at this point, at least I got stuck here, so if you also got stuck here, leave a comment. We're in the same boat. We can comfort each other for this run of misfortune. But so how do we actually get ourselves out of this? How do we proceed forward? If we look on both sides, there's one term that's differing. So maybe we should try to figure out how we can get this one term somehow to change. So let's just look at the case on the left. Now we would realize that if A is greater than or equal to B, we would be very happy because then we can establish a relationship between the terms we want to change. And in this case, AD would be greater than or equal to BD. And what this means is that we already have AB is greater than AC plus AD, right? We already have this. But now, because we've established a relationship between AD and BD, we can continue by saying that AC plus AD is greater than or equal to AC plus BD. Because the only term that's differing, AD here is larger or equal. And now, what happens is we have an unbroken chain of inequalities in the same direction. AB is greater than this, and this is greater than or equal to this. So then naturally it follows that AB must be greater than AC plus BD, and that is exactly what we wanted to prove. So this is fantastic. The problem though is we don't actually know the relationship between A and B, right? So we said if A is greater than or equal to B, then we would be happy, but what if it's not? What if A happens to be less than B? Well, if A is less than B, we can come on the right here because you'll notice that everything above this line on both sides, this is always true and this is also always true. So we can do this. We can say if A is less than B, we can now use the information we've gathered previously. If A is less than B, again, we have one term that's differing, so we establish relationship between those two. And we now have BC is greater than AC. So now we do the same thing. AB is greater than BC plus BD, which we've got here. And then we have another inequality that allows us to go from BC to AC. And now once again, there's an unbroken chain, right? So AB is greater than AC plus BD as well. And we've reached the solution we needed. We've realized that no matter if A is greater than or equal to B, or if A is less than B, no matter what the case actually is, we would have some way of proving that AB is greater than AC plus BD. And this is basically the end of our thinking process as we've already solved the problem. Although there is an even simpler way of solving this, but it does require a little bit of more advanced math. But this here, it's fairly simple. I hope you agree. All that's left would be to clean this up and put this into a format that would be acceptable on a math test or in a math paper. The first thing we need to do is we need to move these conditionals to the top. And obviously now we don't have to say if, we can say since. And we can clean up some lines that were just for our thinking. And this would be possibly close to something you could write as a formal proof. If you want to complete it, you can write a conclusion saying that we combine the two cases above to prove the final inequality. And you can even write QED just to feel good about yourself, and it's a well-deserved problem solved. Anyways, I hope that this is a valuable tool that we can all use. We can think about the next time a similar problem comes along. I hope you enjoyed this video. I hope this taught you something. And if so, please leave a like and comment your thoughts. Thanks for watching.